Welcome back to the deep dive. Today, we are taking a massive leap into a world where high-end computer-aided design meets, well, centuries of traditional jewelry craftsmanship.
We are.
We're diving deep into AlgoJewels,
Right.
where AJ's system designed to, completely transform how jewelers go from concept to a final production-ready design.
And this is such a crucial deep dive for you because AJ isn't just about drawing. It's really about writing the instructions for a piece of jewelry.
Like a recipe.
Exactly. Like a master artisan follows a precise set of steps. So our mission here is to unpack the core thinking behind AJ, understand this huge shift it makes toward algorithmic design, and, well, explore the whole digital workbench it offers.
So this is basically a shortcut for you to understand why experts like graduate gemologist Ralph Schroeder built this system for jewelers, by jewelers.
That's the key.
Okay, let's unpack that core idea right away, because this seems to be where the whole promise of efficiency lies. The sources all emphasize that AJ is the future of jewelry CAD because it moves beyond what they call static modeling.
Right, static modeling, that's the old way. You draw a shape, and if you need to change, say, the ring size or the stone dimensions,
You have to redraw everything.
you have to redraw and rebuild every single attached component. The claws, the bezel, the shank, all of it. AJ pivots to parametric design, which is sometimes called associative modeling.
So can you walk us through a quick example of that? Like how that hierarchy works? Where does the constraint start, and what's the real benefit?
Okay, so the constraint starts with a foundational input. Usually that's the ring size or the exact dimensions of your main gemstone,
The most important variable.
the most important one. And in an AJ design, every other element is mathematically linked to that foundation. So if you have a complex pave band and your client needs to go from a size 7 to an 8, you just change the input slider.
From 78. And then,
And then the shanks thicken just the right amount. The little melee stones all shift their positions to maintain perfect spacing. The pongs adjust their height. It all happens automatically,
yeah.
simultaneously.
That's the difference between, what, minutes of adjustment versus potentially hours or even days of meticulous redrawing.
On custom pieces, absolutely. It's a huge efficiency gain.
Incredible.
And that speed and control, it brings us right to the algorithmic foundation of the whole thing. Every single component in AJ, every definition starts from one place. The origin point, 0, 0, 0, 0.
The source is called as the Big Bang of the design universe inside Rhino and Grasshopper.
It's a great analogy. It's a really structured approach, rooted in geometry, and it's known as the chain of design.
Okay.
Think of it like this. Your design moves out from that center point in a logical sequence. A ring starts at 0, 0, 0 that defines the center axis, which defines the radius, which then defines the size circle, and so on.
So everything builds on the thing that came before it.
Exactly, for its own strength and coherence.
So how are we? How are we communicating these instructions? We're running this inside Rhino, the CAD program, but the actual algorithm work is happening in Grasshopper or GH.
Right, and an algorithm is really just a recipe. That's a perfect way to think about it.
Okay.
It's a precise, written procedure to solve a problem. You know, jewelers already have these recipes, a standard process for making a setting or assembling a head. Grasshopper just digitizes that process.
So instead of physical tools, you're using digital components and linking them with little wires on the screen.
You're linking them with wires in a visual script to create that exact set of instructions.
Now, this is where it gets really interesting for me because we're talking about incredible precision. The source material says Rhino and Grasshopper operate at a tolerance of up to 0.001 millimeters.
It's an extreme level of precision. To put that in perspective for you, the acceptable tolerance for a finished piece of fine jewelry is maybe 0.1 millimeters.
Wow.
So yeah, AJ is operating at 100 times that level of precision, and that means your inputs have to be perfect for the geometry to calculate correctly.
And this leads to that fascinating idea of shaking the inputs. Can you explain what that means? Why do you need to do that?
Well, because the computational engine is always searching for a mathematically complete, closed solution, something solid and printable. If your input parameter, say the radius of a curve, is off by just a tiny, tiny amount,
Like an amount you can't even see.
an infinitesimal amount, the engine might not find a clear path to the solution, the shape just won't generate, or you'll get an error.
So you have to nudge it.
You have to nudge it. Precisely. Shaking the inputs just means making a tiny adjustment to a slider, moving a number by a fraction of a thousandth of a millimeter to force Grasshopper to find the next valid computational point.
And that subtle movement is often the difference between seeing a beautiful form and nothing.
Or a broken calculation. Yeah. It's an act of digital refinement that's just required by how precise the system is.
It sounds like a system that demands more than just design talent. You need a foundational understanding of the structure you're building.
Oh, absolutely. To use AJ well, you need more than just CAD literacy. You need a background in traditional jewelry making. You need to understand hand setting, finishing, casting, metal tolerances.
So that practical knowledge informs how you use the digital rule.
Exactly. And on the digital side, yes, the system does rely on math and geometry concepts. Things like sets, vectors, lists, and domains.
Wait, I don't want you to feel overwhelmed by math jargon here. If I'm an artisan, what should I think of when I hear vector in the context of setting a stone in AJ?
That's a great question. Forget the academic definition. In AJ, a vector isn't some scary math concept. It's just the precise angle and direction you need to rotate a diamond.
Ah, okay.
It ensures that every prong is sitting perfectly perpendicular to the metal surface. It's critical for security and for light reflection. You're structuring your traditional knowledge using these mathematical rules.
That makes perfect sense. Okay, let's move on to the actual digital workbench, the toolkit itself. Since everything radiates from that central point, I assume the foundation has to be defining curves and profiles.
Correct. The core of the system is the AlgoJewels curve stab. Curves are foundational because all 3D surfaces and solids, they all start as 2D curves.
Right, and for